Before I kind of crack on, if you want to connect with me on LinkedIn, feel free to do the QR code thing at the bottom there. You may regret that afterwards. It depends how the rest of the slides go. To give you some kind of just a bit more expansion on my background, I spent nearly 20 years at a company called SAS. And so those who have been in the data science world for a while will probably be familiar with that company. I spent a lot of my time thinking about and designing and advising around architectures for data science or analytics. AI is now known because we like to rebrand things on a very regular basis. And so since then, I've worked in a number of different startups, but that concept of bringing people, process, tech together to basically make better decisions and hopefully make some money or reduce cost or whatever it is, I think is kind of the experience that I'm sort of bringing to bear today. This may or may not be like other sessions. I am not a data scientist. I struggle to add up and subtract and things. So I tend to focus more on the data side of things. And so that's what we'll talk about today. If you're interested, some of the material that I'm going to talk through today is based on a couple of blogs that I've written over the past, I guess, 6 months. One around life cycles, which we'll talk about a lot, and one around this concept of data-driven innovation. Again, QR codes if you want to read more, or maybe not if you've had enough of me kind of ranting on during this session. So I'm going to start with 2 or 3 trends that I want to put up there because I think they kind of give context to kind of where we are, where we're going. And then what I'm going to do is talk a little bit about just kind of how we got to where we are, a brief history lesson, if I'm allowed to do that. And then we will dive into kind of some of this unknown known stuff and kind of go from there. So this is not my quote. This is a quote that I stole from a book called Data Management at Scale: The Inevitable Future of Data is Decentralized. And I agree with this, right? If we think about situations in companies today, there is always onboarding of new data, whether that's third party, whether that's external data. There's onboarding of new systems. You might subscribe to a new SaaS system, like say a Salesforce, for example. You may acquire, I don't know, you may start putting data into a different platform. There's always new data coming into organizations, new applications to support the business. There's always new ways and means of kind of using that data. We'll come on to a little bit more about that sort of disconnect in a moment. But essentially, the idea that we can have all of our data in a single thing is kind of, in my opinion anyway, kind of dead and buried. And so the future as we go forward is going to be decentralized, and we need to think about that when we think about sort of data science. I'll talk a little bit more about data mesh in a slide or two's time, but this concept of data mesh where we decentralize ownership of data, right? So that's different from having decentralized data in lots of places. Decentralizing the ownership. So instead of having a central function that we go to ask for data access, we might go to a line of business, or we might go to lots of lines of business, and those lines of businesses provide us with data products. And so again, this is something that we're seeing is a big trend towards getting that ownership of data out into the kind of the business. This is I think an interesting number, and it might be interesting towards the end or in Q&A if people validate this or otherwise. I spend time with the Chief Data Officer communities in the UK and EMEA, just talking about the various things related to data and analytics and data science and trends and things. And from a kind of an informal survey, I've discovered that CDO organizations typically spend between 10 and 20% of their time on innovation. So, that could be like a Friday afternoon, or it could be a Friday. The CDO basically says to a bunch of the people in their organization, look at the data, look at the tools we've got. What new things, what new ideas can you generate? And that's a different way of thinking from kind of a business-driven question. So how do we forecast customer churn? Maybe that comes from marketing, but maybe the CDO innovation is more like, well, we've got this stuff, we've got these tools, we've got this data. What insight can you generate across different different data stored in different places? And then the last one, last trend I just wanted to mention was this: AI strategy depends on data strategy. And there's a lot of people out there that say this, and I think it's very true. What I see is a lot of people sort of say your AI strategy starts with your data strategy. And I think that's perhaps wrong, because I think your any strategy, data science, whatever we call it, whatever label we give it, analytics, data science, AI, it should really start with the business, right? What are we trying to achieve? But I do think your AI strategy depends on your data strategy. How are you managing your data? What are you doing with it? Where are you storing it? Who owns it? All that good stuff. That is very important when we think about how we're going to exploit maths, basically, to give us better outcomes. I've got two more slides that I just want to talk through before we get into kind of, I guess, what I consider to be the meat and potatoes of the presentation. One is this operational versus analytical lens that we can apply from a data perspective when we're thinking about companies. So, and again, I'm sure everyone's familiar with this, but I kind of like to level set. So when we think about operational aspects, sometimes that's referred to as transactional as well. Really, what we're interested in is the state of the business at a point in time. So if I've got a bank account, I like to know how much money's in it, and I like that number to be accurate at all times. So if I have a bank account and my wife goes and buys shoes, I like to know about that, right? I'd like to know that she's taken a bunch of money out, and I need to put a bunch of money back in to get that balance back. And if we think about that, we need systems that can support that, but we need systems that can support that across maybe millions of transactions. So maybe there's a lot of people whose wives go mad for spending on shoes. And we need all of those people to have all of their data accurate and precise at all times. And that's basically the systems that we see for running businesses. On the right-hand side of this, or for me, the right-hand side, we have this analytical lens or perspective, which is where we are looking to understand what's going on in the business and kind of optimize what happens. And in the same scenario, what we might say is, actually, I'd like to know if all of my customers are currently in credit or they're currently in debt. Because if everyone has a negative balance as a bank, I'm probably in trouble. Right? And so what I'm looking at here is I'm analyzing data across large volumes of data. I'm not necessarily interested in those individual transactions. And to a large extent, historically, this is where we have done the maths. This is where we've built our models based on this historical data. We have tried to understand who's kind of doing what, who's maybe a high value customer we want to retain, and who's someone we're quite happy if they churn, all that good stuff. But then obviously we need to take that and we need to push that into the operation side of the business, that insight, so that we can make better decisions. And we end up with this kind of constant churn, or constant churn's the wrong word, sorry, this constant cycle. And I think what's interesting here is, or I think there's an interesting discussion here about where some of the new technologies fit. So generative AI, for example, historically, I would argue that classical AI, and again, I'll come onto this in more detail in a moment, but it's sat on the analytical side, whereas generative AI, with the outputs being fed into the operational side, whereas with generative AI, I actually think it's the reverse. So that's also an interesting discussion that I'd be more than happy to have with whoever at a later date. But generative AI, essentially, we are generating data, in my opinion anyway, for the operation of the business. And we may want to analyze whether that generated data was good or bad. And that then takes us to the analytical side to help us kind of make that generative AI model, if you like, better. So that's quite an interesting thing, because and I'm sure there's experts here on Gen AI, but I think that's quite interesting because it starts to make us think about analytics in a different way than perhaps what we've done previously. So another thing I want to mention, and I said last slide or so before I get into the kind of the presentation proper, is this evolution of data for analytics, and this has happened in my career. When I sort of started messing around with data a very long time ago, we used to build data warehouses, and we used to have data models. So we used to essentially bring data together from lots of different places. We used to model this data really tightly in a third normalized form. For example, like, there was the Kimber-Inman wars, all that good stuff. But we used to model stuff. We used to, and the model was basically let's model the data as it was, as reality is, right? So we would have a customer subject, and we'd have a transaction and product, all that good stuff. And we used to store those on files, on file systems. And even quite large, or back then, quite large systems. And so, a warehouse would basically be some sort of engine and a collection of data in these files. And we'd have a central data team that was basically responsible for kind of managing this, for onboarding new data, for responding to requests. Essentially what happened over a period was folks like Oracle and Teradata did great marketing and told everyone to move away from files and put all this data into their thing, right? And that's what happens. And so data warehouses kind of became synonymous with a kind of a technology, but that's not really where they started, and really what a data warehouse is. A data warehouse is essentially the collection of data. Over time, and I guess into the sort of 2010 timeframe, we saw the adoption of Hadoop, and Hadoop came along primarily because we wanted cheap storage, and we wanted a place to put data that wasn't necessarily structured. And so that comes along. We move away from the warehouse, we move away from data modeling, the whole schema on read, schema on write debate. So previously we had this thing called schema on write. We would structure the data in a particular way so that when people read the data, it would be modeled and it'd be easy to understand, and consumers could get value quickly. We moved towards a different paradigm called schema on read, which basically meant that your data scientists and your analysts and business people would have to basically figure out the data and almost generate the model at runtime, schema on read, figure out what's going on. Again, central data team. And the interesting thing about this is in my experience, the central data team basically became a central technical team because they had to focus on keeping Hadoop up and running, because Hadoop is a bit of a nightmare when it comes to just operating. Then, move forward, probably mid-2000, let's say 2015, something around there, we see the kind of a movement away from Hadoop, but towards the adoption of cloud, right, and cloud data warehouses. And that's kind of interesting in itself, because we move towards things like Medallion is an architecture that's talked about nowadays, which is basically the warehouse methodology that was developed back in the 90s or 80s. It's really interesting. I don't see very much data modeling going on in the cloud data warehouses at all. And I know that data modeling, I think, is going to make a comeback, but at the moment, there's not a lot going on there. And that struck me as interesting because, if you modeled your data well, your cloud costs would reduce. Then we're starting to see the adoption of object stores, files. So putting the data in files again, which is again something we did back in the late 90s. So putting data in Iceberg or Parquet or Delta or whatever on an object store in a cloud for a cloud data warehouse to run. Still a central data team, right? So if I want some more data into that thing, I typically have to go and ask someone to get some data into that thing. And we'll come on to why that's problematic in a moment. And then the last one on here, the white block, is data mesh, right? And I'm not going to spend a lot of time on data mesh, although I could. But data mesh, I think, as a term, has kind of come and gone. but the principles, I think, are slowly creeping into pretty much every organization I speak to. This idea of having individual functions build individual pieces of data, which are relevant to them, modeling that data, right? And now the model can be really, really simple because we're only interested in a specific area. So that might be, let's say, a list of customers who are going to churn, right? I can model that data. I can make that available as a data product. If I define a data product as being simply some data and context around it, to make it easy to find and useful, and I can model the data really easily, and I can store it wherever it makes sense, right? And now, because I have like a marketing function or a finance function or a logistics function or whatever owning that data, I now don't have a centralized team. I have decentralized ownership. And I would argue that this is, we're kind of seeing this being adopted. I'll come on to why this is kind of relevant in a moment. I have to do the obligatory Starburst slide. So this is my, this is kind of just to let know what kind of Starburst is. So Starburst is an engine that kind of sits between user interfaces, like the BI tools like Tableau, Power BI, Looker, etc. And some of the more data science focused things, I think, like Python libraries, Jupyter notebooks, etc. Sits between those and data and data platforms and data engines, and hides away the complexity of connecting to those, allows you to very quickly, I should say, discover data, right? Find data that's relevant, find data that's in different platforms that's the same, or you thought was the same, and look for look for potential issues between different data platforms, as well as looking for correlations and data that's kind of similar and correlates in some way. So lots of the things that you do, I would suggest, at the beginning of a kind of a data science process. Starburst itself, based on open source Trino, Presto, and really a very highly scalable SQL engine is basically what we're talking about in the middle layer. Does lots of things: governance, security, data products, scalability, etc. That's really what kind of Starburst does. And so if we go back to that idea of decentralized ownership and people in lines of business being able to want to just connect to stuff and see what their data looks like and join it with other data, Starburst has got quite a lot of features that kind of make that easier to do. So I'm going to switch gears quite significantly and jump into kind of two types of AI that we see. And I have to keep talking about Gen AI because everyone has to talk about it because it's the flavor of the month and it's going to change the world. I'm sort of slightly more skeptical because I've seen a lot of these new waves come along before. And I'm going to focus for the rest of the presentation mostly on what I've called Generation 1 or classic AI. I don't have better words for it, I'm afraid. But it's interesting. I see there's a lot of, frankly, there's a lot of nonsense talked about generative AI. Generative AI is a probabilistic system, right? You get an answer that's probable. It might be factual. We don't know. It's definitely going to be probable. Whereas with classical AI or data science, if we think about logistic regressions or I don't know, structured vector modeling or any one of the clustering techniques, we're going to get a factual answer, right? We're going to add two things together and we're going to get a number. We're probably going to get the right answer with generative AI, but we may not. And this comes down to the fact that people say, "Oh, generative AI hallucinates," and that's a terrible thing. Well, and I'm sure everyone on this call knows that hallucination thing is what it's doing, right? It's coming up with a probable answer. It may be incorrect, but that probabilistic approach is essentially hallucinations. Then, if we just drop down to right at the bottom here, I think where this fits is generative AI is really useful for subjective decision making. So, if I get some data and I want to know what I should do next, perhaps generative AI is really useful for that. Whereas to get that data in the first place, I probably am going to rely on the classic approach, where add these two numbers together. What's the answer? That's going to be giving me a number based on that information. Now I wanted to figure out what I'm going to do next, and I think that's where we're going to start seeing that sort of generative AI piece fit in. I think there's a lot of value there. I'm not sure we've figured out quite how we generate a lot of value yet. I see a lot of people talking about code generation, and that's wonderful. I think if that's where generative AI kind of stops, then I think we've missed some opportunities. So I'm positive there is some use cases and some value in generative AI. I just think we need to think about kind of where it fits. And as I say, for the next few slides, I'm going to really focus on this kind of generative, this Gen 1 or classic AI, for want of a better term. When I talk to organizations about sort of AI or data science, I like to get them to draw out things on a whiteboard, right? To tell me kind of where things are good and where things are difficult, where they've got challenges, et cetera, et cetera. And this idea of kind of a life cycle of, well, we have some data coming into these systems. We want to eventually make these decisions, and how do we get from one to the other? Who's involved? What are the business processes? What are the technical constraints, et cetera, et cetera. It's a really interesting. It's always really interesting to do this. What I have kind of taken away is broadly everything fits into 3 steps, right? And again, this may sound obvious, but I don't see many people kind of putting this down onto something simple. So the first step is basically data discovery, or the first phase, I should say, is data discovery. And what we're doing here is we're trying to figure out what data is in an organization, what data I can use, what data I can't use, where that data exists. Getting access to that data in the first place is also part of this. Once I've got that data, and I think I've got some data that's relevant to to my question, then I move into this model development phase. And this is basically where I'm applying maths to that data, right? Whatever those algorithms are, the statistical techniques that I want to use, I'm applying those to figure something out. And once I've built that model, and I'm going to use the term model, I want to deploy that, right? And I want to put that into somewhere where some decision maker can make a better or different decision, which ultimately makes some money, because then that helps us recoup the cost of this investment that we have to make to go through this process. Now, in each of these phases, there's a lot of activities that kind of you have to go through. So this isn't. I'm not trying to simplify this too much, but I just think we can kind of aggregate up these phases into these 3 areas. This idea of discovery, development, and deployment. In between, on this slide, what I've put is I've introduced the concept of data products, and the reason for this is because I think data products actually fit really nicely in the data science world, right? If we're going from discovery to model development, I may want to create I know people talk about feature stores. Historically, we talked about analytical base tables, but I may want to create essentially a collection of data that is relevant to someone then building a model. I may want to give some semantic definition, maybe some provenance information, maybe some ownership of the data in terms of what systems it comes from, maybe some quality metrics. I may want to give that or store that away and make that available to the person who's doing the model development, because it may be multiple people who want to use this data product. So I've discovered some data, I built some data products, I have all this contextual information as well as the data, and that enables me to scale my model development piece, right? I can build different models on perhaps those data products. And the output of my model development may in fact be, as I say, a model, a piece of code, or it could be some data, but in either case, we could wrap that up as a data product, right? So now we have this this piece of code, and then we go into the deployment. And again, the output of that after we've deployed it could be a kind of data product, which is why I've kind of put those data products in there. The observant people will have noticed the data discovery cycle is large. And the reason it's large is because that's typically where the problems begin and end. Not always, but that's typically where the problems begin and end. And so an awful lot of time is spent on that first phase, all the activities therewith. And so I think, depending on which analyst you kind of read, they will tell you inevitably it's somewhere between 60 and 80% of the time to get through this process is spent on data discovery. And I would argue that that's pretty low value stuff, right? That's pretty low value in the case of this cycle. Where the high value activity is in building a better model, building a better designed model, a model that is more accurate, a model that's perhaps more useful, right? We may have the most accurate model in the world, but if we can't deploy it, then frankly, that's not useful, right? So this model development phase is really where kind of the value is. That's where the money is. But we're spending most of our time as kind of data people, for want of a better term, in the data discovery phase. And I think that's kind of problematic. And if I kind of expand that out a bit and think about it from a time perspective, we think, everyone's aware of query response times, right? So how long does it take me to run a query and get, I don't know, 1 million records or 100 records or whatever it is that fulfill some criteria? Actually, when we think about this, we need to think about the data management process as well as the query response time. I remember doing a project for a large bank based out, so a multinational bank, but with offices in London, where we were doing some form of credit scoring. And I can't go into too many details, but we were doing some form of credit scoring. And the actual process to score the customers was taking, sort of, I think it was about 22 hours. And that was cool. They were quite happy with that at the time. This is going back probably a decade. It took 9 months to get the data into that form, into the form that they could use to run these credit scores. As part of the project, we were able to bring down the query runtime from 24 hours to about an hour, which was very respectable. But they didn't really care, because we were also able to bring that from 9 months down to about 4 weeks. And so the data management process of this is kind of far more important than the query response time ultimately. And so, when I talked about getting access to data, well, why is that a problem? And if we kind of unpack that, we can think that if I don't have the data in a place already, don't have it in a thing, if I don't have it in a lake house, a warehouse, in an object store or pre-prepared or whatever, then someone's got to do some of this work. And that involves, the ELT, ETL, CDC, lots of acronyms. It involves typically storing data in multiple places. A lot of times this is done by someone that's not in the line of business. And that's problematic because, again, what this inevitably means is multiple requests are made. So I, as let's say an analyst or a data scientist, I say I need some access to this sort of data. I'm not allowed access to the source system for whatever reason. So you in the central data team, can you make this data available? They give me something, ideally in a time frame that it's still relevant. Once I get that data, I can then figure out how useful it is. And if it's not useful, either because I didn't specify it correctly or because they didn't understand or for whatever reason, then I re-request and we go through this process again. And this, of course, assumes that the folks that are doing this work for me in the central data team are kind of sat around doing nothing. And that's not often the case. Normally, they're pretty busy. And so when I ask them to do something, it's basically a ticket in a queue. And so this is why that whole data discovery piece takes a lot of time. And we could get into the whole spectre of shadow OT and all that good stuff. But broadly, this is something that I think we kind of want to try and avoid. The other thing I'll just add on to this, the other dimension to time, of course, is cost. Right? So running a query, may cost a cent or a dollar or a pound or a euro, or it might cost 1,000 or 10,000 euros or whatever it is. But again, that data management process could cost tens of thousands of dollars or hundreds of thousands of euros or whatever. And so I've kind of mentioned this previously, that three steps, the discovery, development, deployment, that's all cost. Right. At some point, someone needs to make that better decision or a number of better decisions probably, to kind of offset that cost. The longer we spend on that discovery phase, the higher that cost. We have to figure out, actually, is this even a viable project? So it might not be just how long it takes us to get to a result, which may or may not meet the requirement of the market. If our competitor introduces a new product or service and they're doing something tomorrow, it's no point us having a better result in a month's time. Similarly with cost, right? If we're going to get a return of 5, but it's going to cost us 10 to get there, then we shouldn't do it. I would suggest that a lot of organizations still go ahead because they don't have the clarity of those numbers. So this is all kind of presupposed on this idea of trying to sort of bring data together, right? This idea of this data management process and this kind of time and cost, bringing data together or relying on someone to bring data together before we kind of get into into discovery and development. And I guess it's time to kind of reframe that a little and think about that in maybe a slightly different way. And that's where some of this ideas about known and unknown ideas and concepts come from. So I would say probably somewhere between about 2010, 2015-ish, Gartner produced a paper, and actually Gartner produced some quite interesting stuff, although from looking at it from the outside, it's not obvious. But some of the papers they produce are quite, really insightful. And this was one where they come up with this model of known and unknown questions and etc., known and unknown data. They went in a different direction to how I'm kind of using it, which is why I've kind of titled this "Reimagining the Data Management Quadrant." And if we were to kind of put some labels into these 4 boxes, and I'm going to unpack these in a little more detail in a moment, but if we were to put some labels in, we can think about, number 1 is this concept of centralization, right? So bringing all the data together into a single place. That's what we do if we're known and known. Then we've got number 2 up there is kind of more understanding of data. Number 3 is more kind of discovering data, and number 4 is kind of experimentation. And if we break that out, we can think that if we know the questions that people are going to ask, and we know what data we have to answer those questions, we essentially have a data warehouse, right? That's what a data warehouse was designed for. We know those subjects: customer, transaction, product, whatever, and we know the sorts of things people are going to ask about them. And if all of the data we need for our kind of data science process is known, and the people who built the data warehouse built it in such a way that they kind of knew about the questions we were going to ask, then that would be awesome, right? The reality is that doesn't happen very often. Number 2 is really where we're starting to think about, from a data perspective, what are people likely to want to do in the future? And actually, I think this is where the concept of OLAP comes in. So where in the past, we used to design these things called cubes, and we called them cubes because a cube is multidimensional, even though actually what we were sort of looking at was kind of hyperdimensional, I guess. So what I mean by this is the person who was designing the data structures would say, we've got some data on sales and some data on revenue and some data on cost. let's say. Uh, we also have some data about the geography, about the line of business, about the brand, about the, I don't know if it's shoes, about the color, about the style, about the price, right? We have all this data. So let's just structure it in such a way that someone can say, I'd like to understand this particular metric, the sales of the shoes, by the location or by the, aggregated by or summed or whatever, by the by one of the dimensions. So, shoes by region, or shoes by price, or shoes by color, whatever it is. And again, if the questions that I have can be answered by these structures, this known data, then that's awesome, right? I can do that data discovery thing quite quickly. What's more interesting, I think, and this is an area that I think a lot of organizations are less good at, and ironically, I think this is where more sort of data science requests sit, is where we have a known question, right? So we have a question, maybe it's, how many customers are going to churn next week, or how many shoes are we going to sell next week? We may not know what data we have. And when I define unknown data, what I really mean by this is data that we haven't really put in a thing. Right, it's data we haven't structured, we haven't modeled, we haven't brought it together with other data. It's data that exists in the company somewhere, or exists in the enterprise, or even outside the enterprise. It's data that exists. We don't really know about it because we've not kind of done much with it in the past, or anything with it. So this idea here is where we're trying to access data without really knowing about it, but for some particular reason, right? So in this case, to predict the number of shoes. And I talked a little bit about Starburst and this concept of accessing data across different places. This is where that comes in to be useful. The alternative approach is very much the, can I get access to the system? Can I get access to this data? Excuse me. I was going to sneeze, but now I'm not. There we go. So yeah, can I get access to this data? Can I get access to the system? And kind of spending a lot of time in that data discovery step in the analytical lifecycle. And then the fourth one, I've pressed the wrong button. The fourth one is basically thinking about those chief data officer organizations. So in that case, this is a central team who doesn't really have a good context of the kind of the data itself, but has access to lots of data and lots of tools. And they're encouraged to spend an amount of their time to experiment, innovate, try stuff out, see what's going on, see if there's interesting correlations between this data. So we're not kind of targeted. We're not driven towards a particular business objective here. We're literally saying, actually, I can see that there's a customer key over here, and I've got a customer key over in this other system. And interestingly, they don't match up. And why don't they match up, right? So we're kind of driving some innovation around perhaps understanding, is it just a cleanliness thing, or is it actually that we have customers who are the same customers who in real world, but are somehow identified differently in two different systems? And that might be useful to know for us to understand how our customers are behaving. So we talked about all those different quadrants, and I guess bringing that back to kind of data science, because this is the sort of data science festival after all. I would suggest that what we should be doing, and what we can do, is we can kind of switch this around. So what we can do is say, actually, if I can give access to my data scientists or my data engineers or whoever who live in those business functions, if I can give access to those guys I should say guys and girls, let's say folks, to those people, if I can get access to that data, I can spend much less time, right? Obviously in governed and secured way and all that good stuff. But if I can allow the data scientists to access the data without having to ask somebody, to just try things out, we can radically reduce the amount of time we need to spend on data discovery. And by doing that, we can radically increase the amount of time that we spend on model development. Um, and by doing that, that gives us the opportunity to build better models, build more accurate models, to hopefully get a better result when we deploy this model, and the decision is made, or a better decision is made. And so this is kind of where I think I'm going with this. Is this we don't necessarily know what the data is. We don't necessarily know what the or in this case, we probably know what the question is, but we don't necessarily know what the data is. We can't possibly bring all data together into a single place before we start, because that the future is decentralized. So how do we go down a middle ground which allows us, our data scientists, to do this, to radically reduce the amount of data time and data discovery? And I think these technologies that allow us to kind of hide and abstract away technical complexity, give data access, are basically going to be very valuable in this process. Now, I'm just going to sort of tip my cap, I guess, to generative AI. So in this case, this data science lifecycle, I'm really thinking about that sort of classic AI, the sort of machine learning stuff that we've done, for a number of decades. But actually, if we take that this same life cycle and we think about Gen AI, I would strongly argue that the process is the same. Right? The data discovery piece is interesting in itself. People are collecting huge amounts of data from typically from the internet. There's a lot of work that needs to be done, though, to make sure that data, as part of that process, you're removing biased data or data that's sexist or racist, or has problems with it. This is data you do not want into your model. So there's a lot still of work that happens there. The model development is kind of your model training, and then the model deployment is how you're going to kind of access that model. So I would contend that perhaps the individual activities that we do within each of these stages is going to be different. That overall life cycle, I think, is going to broadly be the same. And then I guess, and this isn't this slide needs a little bit of work, I feel, but I just want to make the point that I've kind of presented this as a linear left to right, and actually that's never the case, and that makes this kind of much more complex. We often will move from data discovery to model development and then back again. And we'll often jump certain activities in data discovery, and then realize that actually we shouldn't have jumped them, and go back and forth. And so, maybe we get all the way through to model deployment and we decide actually, this model is awesome. It gives us, a 90% accuracy, but the reality of running it every single time we need to run it is too costly or too time consuming. Therefore, we're going to go back to model development to perhaps focus on training a model that's maybe slightly less accurate, but able to run within the kind of the constraints that we have. And so, I don't want to. I've presented it as a left to right just for simplicity, but in reality, there's an awful lot of back and forth between each of the different steps. And so that data discovery phase, which I keep banging on about, that can then become more important because we move forward and we move back to discovery. We move forward, we move back to discovery. If getting around that data discovery phase is problematic, then it's going to continually slow us down. And then basically that's kind of me done, and I just wanted to show some QR codes for a couple of books that I'm a co-author on. If people are interested, I won't be offended if not. One on data products and one on data mesh for dummies that can be downloaded from the Starburst website. And then I guess that's kind of me done.